RBS Visit Research Academy welcomes to you in the second lecture on Smart PLS. I want to inform you that I have started a series of the lectures on Smart PLS. So this is the second lecture of this series. In this series, I'm going to discuss the difference between the partial DC square structural equation modeling, which is a part of the variance-based structural equation modeling, and the covariance-based structural equation modeling, which we call as the CB-SEM. So dear viewers, it is very important to understand the difference between these two approaches. After understanding the difference between these two approaches, you will be sufficiently able to choose the right method for your data analysis. Otherwise, probably you may not be able to find out the right approach to analyze your data. So from that point of view, it is going to be a very important video, and I hope that you will watch it completely. My name is Dr. Rahim Sumro, and I'm from the Shabdati University, Pakistan. So I feel a pleasure to inform you that I'm a SmartPLS Academy certified trainer. So this is the certificate which was generated, which was awarded by the SmartPLS Academy, Hamburg University from Germany. So these are the 9 courses which I completed during this online course. And this is some detail about this academy, and these all are the courses which they are offering. All these are the paid one, because you know there is no free lunch in the world. In the same way, you have to pay for all these 9 courses. And additionally, 2 free courses are also available. And but if you want to get certified from this academy, then you are required to go through all these one by paying some amount. This is the website address where you can find out this SmartPLS Academy. Now I'm discussing about the difference between the CB-SEM, means the covariance-based structural equation modeling, versus PLS, partial least square structural equation modeling. These are the 2 methods available to the researcher. As I already told you, that these 2 methods are available to you. So one is a covariance-based, and other is a variance-based partial least square. Other is a variance-based. So as I told you that the difference, to understand the difference between these 2 approaches is very important. So that's why I have developed this video to teach you how you can differentiate between these 2 words. Conceptually and practically, PLS is similar to using the multiple regression, because the CB structural equation modeling, it may be PLS or it may be covariance based like the MOS. Both are basically the second generation approaches. The first generation approach, in which normally we apply the regression, multiple regression, like it is written here, and another factor analysis. Now that's why the second generation approach, they are also using these 2, multiple regression as well as a factor analysis. And then CB-SEM, its objective is what? Its objective is to reduce the theoretical covariance matrix without focusing on the explained variance. CB-SEM basically focus more on the covariance matrix and less on the explained variance. Now, explained variance, it means that it focus on the R square. The value of the R square, higher the value of the R square, higher the explained variance is there. Lower the value of the R square, lower the explained variance is there. So that's why the CB-SEM purely focus on the covariance matrix, and the PLS-SEM is basically focused on the explained variance. Now, explained variance, it's the other term of the name of the R square, and this is called the endogenous. Endogenous means your dependent variable. Explained variance, we can understand that the total impact of all the independent variable on the dependent variable. This type of the thing, this type of the approach is called as the explained variance. And then there are the two approaches are there. One is a common factor and another is a composite factor. So what is the difference between these two? One, let's to understand about the common factor. Common factor simply tends to explain the model fit and you interpret whether or not factors in the model fit are. That means here basically it focuses on the either the model is fitting in the data or not. So for this purpose, there are different indices are there, and these indices we call as a goodness of fit index. So if the majority of indices are within the range, within the range means that within either they are higher than the required value or they are the lower than the required value, that means that our model is fit. So that's why CB-SEM more focus on the model fit. That's why the different goodness of fit indices are there. On the other hand, composite model is used when you have a variable that is based on the several dimensions. That means sometimes we are required to work on the different dimensions. Sometimes your model is too complicated, like there is a independent variable, there's a dependent variables, as well as mediator, moderator, control variables, some other variables. This type of the model we call as a complicated model. Like we are saying here, the complicated model, one example of the complicated model. In other words, we can say the composite analysis is for you when you have a more complicated latent variable. So now the composite model we can apply when your model is so much complicated. Like you are seeing here, this type of the model is so many complicated because the direct path, indirect path, and different variables are there. On the other hand, sample size also a big matter for to choose common factor model or to choose the composite model. While the factor model requires large sample size, here large sample size sometime because it is subjective term. We cannot, I cannot give you any like the exact number of the sample, that means which we can call it a small or we can call as a large sample. But for me, this is my approach. That means if whenever you have a sample, if its size is less than 100, it means it is a small sample size, and when its size is more than 100, it can be called as a like the big like the large sample size. But even though if it is like the sample size is more than 200, 300, surely it's a large sample size. So now when you have a large sample size, then the CB-SEM, like CB-SEM, like the common factor is a good approach to choose. And when you have a small sample size, like less than 100 or even less than the 50, then a composite model is a good choice to apply over there. So this is the basic difference between the CB-SEM and the PLS-SEM. And then CB-SEM, PLS-SEM, CB-SEM is a parametric. It's a CB-SEM like we are using MO is purely a parametric approach because there are certain parameters are there which should be followed. One of the example here is about the data normality. So for this purpose, your data should be normal. And if the data is normal, then you can apply CB-SEM. Otherwise, you have to get your data normalized if it is a non-normal data. PLS-SEM, on the other hand, provides you one good approach that it's a non-parametric method. It does not follow any type of the parameters. So it's a good thing if your data is non-normal or if there's any issue, that means that then even though the PLS-SEM can handle it, then it is a non-parametric test. So sometimes we are using the bootstrapping. Bootstrapping is a technique where the software divides your whole data into the small sample, like the 5,000 samples, sometimes 7,000 samples, depending on the number which are given to the software. And what is that? It providing the standard error to estimate the parameters. So now directly, if there is some parameters not available in the PLS-SEM, so that's why we are required to apply bootstrapping. And then results. So now, which software is providing results? Now, if let's to compare these two, both are the same model, but they are providing results in the different way. How Structural equation modeling like the PLS SEM also considered as a model's predictive capabilities, because you know that this is going to apply when we want to predict the model's capabilities, or when our data is exploratory like this one. So in this one, normally we can apply the CB like your smart PLS. So that's why typically it's provided coefficient of determination, normally we call is a R square. So again, reminding you, the R square means the overall R total impact of contribution are the variance of the independent variables into a dependent variable. Higher the square, the better the predicted prediction of the model. And then CB-SEM is it provides you some of the goodness of it index, because we applied this CB-SEM to test a well-established theory, like the theory of the planned behavior, theory of the planned behavior. So that style is a well-established theory. Is that if you want to test this one with the CB-SEM, may be a good choice for you, because not only this is the criteria, but some other criteria are also there to choose. But if you want to test a theory, established theory, then this choice is good. But when you want to develop a one theory, then the PLS-SEM is a good choice for you. Geo goodness of it index is a measured by the chi-square. We measure by applying the chi-square statistics, and then what it does that which indicate the difference between the covariance matrix and the estimated covariance matrix. So now these goodness fit indexes, they are providing the difference between the covariance matrix and its estimation. So normally the different goodness fit index are available, like the CFI, GFI, AGFI, TLI, and RAMSI. Normally we call at the time the RMSEA. Detail is available of all these one in the next slide. But when you talk about the PLS-SEM, so now, unfortunately, there are no established goodness of it index measures for the like the PLS-SEM. Dear viewers, so here you see there is some goodness of it indices are available, and these are the criterion guideline, and these are SM users. So now basically we divide these one into the three categories: absolute fit measure, incremental fit measure, and parsimonious or parsimony fit measurement. Researchers has advised that at least one should be taken from the absolute of the fit measure, one should at least one should be taken from the incremental, and one at least parsimony. So at least the three measures should be there to justify the fitness of your model into the data. That's very important. So these are the values are there. Now, for example, GFI, goodness of it index, if it is like the more than 0.8, then it is that means your model is fit. It is this part of your model is fit. And root mean square error approximation, normally we call RAMSI. And if its value is less than 0.1, or ideally if it is less than 0.8, it is a wonderful. So these are some of the like the guidelines are there. If your data is less than this one, that's good for us. So rest of the criterion guidelines are available. Please go through yourself. And then these are some of the differences between the CB-SEM and the PLS-SEM. So now these are going to tell you the means of which approach you should choose depend on all these. Now, for example, CB-SEM estimate model parameters so that the discrepancy between the estimated and sample covariance matrix is minimized. The discrepancy between these two ones should be when you want to minimize this one, then this approach is good for you. Assume multivariate normality is already I told you that there is a parametric approach. That's why it requires normality or the normally distributed data. There should be no skewness, there should be no kurtosis. And then it generally requires higher sample size. Higher sample size means the more than 200. Define convergence is an increase or decrease in the function value beyond the certain threshold. It defines in convergence the model Sometimes it decreases, sometimes it increasing, depends on the certain thresholds. Offers goodness of it index. In last slide we discussed about the goodness of it indices. So now CB-SEM offers all these one. Treat construct is a common factor. Already we talked about the common factor and the composite factor. On the other hand, PLS-SEM estimate the model parameters so that the explained variance like the R square of the endogenous means the dependent variable should be maximized. Makes no distribution assumption like here. If your data is a non-normal, then PLS-SEM is a good approach. If your data is normal, then the CB-SEM is a good approach. If you have a small sample size less than 100, then I think this approach is better than this approach. And then it's also defined convergence is the point which no substantial difference occurs from the one iteration to the next. Iteration means the like the repetition. When you repeat the one thing, when you repeat again, the one time occurs when you reach on certain point when there is no difference. So that's why this is another difference between these two ones. No established goodness of it indices, as already I told you, just it provides you the R square, and sometimes researchers they also report the Q square. Like this offers you the like the several goodness of it indices, but PLS-SEM does not do so. And treat construct is a composite, and while this treat construct is a common factor. So these are some of important factors are there. So considering these factors, you can choose your approach. Now, basically, CB-SEM is purely or majorly focused on the theory testing. So now, if you want to test a theory in your own environment, then you can apply the CB-SEM. Like as I already told you, the theory of brand behavior, if you want to apply anywhere to understand the purchase intention of your customer. So if you want to apply this theory, then CB-SEM approach is good because majorly it focuses on the like the testing theory. Otherwise, if you want to develop the theory, if your work is exploratory, then the PLS-SEM is a good approach for you. Dear viewers, now we are coming here. Why? Now, earlier I provided the difference between the CB-SEM and the PLS-SEM. Now here, why we should choose the PLS-SEM approach over the CB-SEM approach. This now, here you are going to understand the answer of this question. So here, objective is to maximize the explained variance, as I already told you. And then its objective is the theory development and prediction, not the theory testing. Majorly, it's an objective. Normality is not required here because it's a non-parametric test. And then it can work with a few indicators. Like here you are like in this model, in this PLS model, you have seen this. So there are two indicators there are two variables are there. There's only one indicator. So even though if there's a one indicator, the SmartPLS will provide the results of all these, even if there is a one indicator. But this is not the case when you are applying the CB-SEM. So especially in the MOs, because most of the time I have worked in MOs, so I know that if there are the less than 3 indicators of any variable, so then in this case, the SmartPLS is not providing the complete results of that one. Although the partial results may be provided to you by the MOs, but not the complete, because it is a limitation of the this one, because it requires from at least 3 indicators are there, because it's a covariance approach. So the one indicator is related with another one, and that one is related with another one. So there is a relationship among all the indicators are. So that's why it's important. At least there should be the 3 indicators in a one variable. So now if 3 indicators are there, like you're seeing here, the 3 indicators, so now the MOs will be in a position to provide you the results. Less than MOs cannot provide you any results. And then model can include large number of indicators, as many indicators as you can provide here in the SmartPLS, but this is not the case with the MOs. MO, it is very difficult to handle for the MOs if the your indicators are more than 50. And then the preferred alternative approach with the formative. Now there are the different. Now there are there are two types of construct. One is a formative and this is reflective. On the next slide, I have discussed the difference between the formative and the reflective. Now, when you have a formative construct, then the PLS SEM should be used, and when your constructs are the reflective. When your constructs are reflective, then you should choose, I think, MOs rather than you should give priority to MOs over the PLS SEM. But if you have the combination of these one, mixture of these one construct is reflective and it is a formative, then again reflective, then again formative. So in this case, you should give priority to the PLS SEM over the MOs, because MOs cannot handle properly the formative measurement models. And as I told you, one benefit is there that even when there's a single item, even though your SmartPLS can handle it properly. Assume all major variance, including error, useful for explanation of that. So now here is a discussion the difference between the reflective and the formative. So okay, this is a reflective. Now what it does, that the reflective, these are the items. These are the item 1, 2, 3, and 4. These are 4 items are there. So now the arrow is pointing out from the construct to its item. Now see, this is the pointation of the arrow. It's coming from the construct to that means a variable to its item. And here formative is mean that when the 3 or 4 whatever number of indicator, when they combinedly make a one variable. Now see here 3 items are there and combinedly they are forming a one variable. So now here if you see that the pointation is from the indicator to a variable. So this is the difference between the reflective and the formative. So now these are here, or this is here. These we call normally as an item, but other names are also there. Item, indicator, measure, variable, observe, or manifestation. So these are different names are there of the same thing. Now here is an example to understand actually. So here we talk about the diet. So now most of the people, they are very much conscious about their health. So that's why they are giving much importance to their dieting habits, eating habits. Now see, now this is question number 1. I eat healthy food. I do not eat much junk food, and then I have a balanced diet. So in the reflective watch, there is basically we are asking the same thing several times from the same respondent. And then we want to check the response of the one. Now, for example, if you are saying that I eat healthy food, if you say strongly agree, then I have a balanced diet. You should also choose the at least agree or strongly agree. So now it's required. Logically, if you think that the answer of these two one should be at least same. And then here you should choose the strongly disagree or disagree. So this is now because it's giving reflection of the one question item should be same from the item number 2, 3, whatever. So that's why here indicators must have highly correlated. These are highly correlated. That at least that the correlation should be 0.3 and above. In this case, because they are going to make a one like construct a variable. So that's why our construct is health. So now these 3 things are going to form a health construct. Now, if we talk about the health, then different things are there. For example, diet is a very important part of the health. I have a balanced diet. Exercise is also a very important part of the health. I exercise regularly and the sleep each night, sufficient sleep. That's another component of the health. So now see that questions are different from each other. So that's why there's it's not normally required. There should be the sum of the correlation among these 3 ones. Sometimes there's a positive correlation, sometimes negative correlation, and sometimes there is a no correlation among them. So now this is the basic difference between the formative and the reflective construct. So now Again, I'm repeating that if you are a reflective construct and big smart sample size, then I think MOS is a good approach over the smart PLS. But if you have the only formative, then then the MOS is not a good approach. But if you have to mix it out, again, the smart PLS is a good approach to choose. And then here, justification. Why we should use the smart PLS? Smart PLS, as again I told you, estimate the coefficients and maximize the value of the endogenous, like the R square. Primary objective is the predictive and the explanation of the target construct. Okay, and is support reflective and the form. I think this is the biggest advantage of the MOS of the smart PLS because it handles both one. No assumptions. Again, it's a good another very important benefit of the smart PLS over the MOS. Small sample size. Again, it's another good advantage smart PLS have over the your MOS, and complex model can handle. Again, it's another very good advantage smart PLS has over the MOS. So these are some of the reasons. When you have these are the reasons, then the smart PLS is a good option than the MOS. Okay, and then here, why PLS SEM? Now, according to the here answer, and they say the PLS is getting more popularity, and there's no doubt. Nowadays, the people are much more, they know about the smart PLS. Although different softwares are available in the variance-based certification modeling, but even though smart PLS is much more popular than all others. And the situation where the theory is less developed, then in this case, smart PLS is a right choice. And then this is the graph which shows the popularity of the smart PLS. It started probably in the 1980s, and then now see in the 2015 continuously its popularity has been increased. The use of the smart PLS has been increased among the researchers. And these are the, as already I told you, these are the different types of the softwares are there which you can use. These are the variance-based softwares are there, and these are the variance-based, and earlier these were the covariance-based softwares. At the end, now these three books are available to me. Their soft copies are available. All these are this primary book on the smart PLS written by the Joseph here. You know, a very famous professor, and he also written the multivariate analysis, which is the very famous in the different business schools across the world, and the Christian Ringel and Marpeda. The same author, they have also written this one, and this is an advanced one. Some of the points which have not been discussed in this one, these have been discussed in this book. And this blue book are there. It's a comprehensive book on the certification model. If you require, please just send me. I can on this email address, I will provide you this free of the cost. At the end, thank you very much for watching this video completely, and I hope this video has cleared you so many misconceptions or your understanding regarding the which approach to choose, either PLS or the CB-SEM. So very soon we will meet another video. Till that time, goodbye.